All right, guys, we have had power outages and internet outages today, so hopefully we can get this done before anything else goes to squat. So let's see. Today we're going to actually put two different lessons together today because they go together like just like a ball and glove. So what we're really talking about here is the alignment between the Earth, the Moon, and the Sun. If you watched your lecture from the other day, you got lots of information right about the moon phases and what that means. And so today we're kind of moving on with that same concept here, same standards, 1-1, how energy is transferred in space. Again, that light is key to what we're talking about, especially with phases there. And then mathematical or computational representations to predict the motion of orbiting objects in the universe due to gravity. Okay, that'll really be a very good segue for us into the next part, which is talking about the rest of the universe. Okay, and how gravitational forces work within the universe. So still same standards here, and then we're really building on those concepts of phases. The essential question for today: how does the moon impact Earth's tides? Okay, we talked about a little bit about this in class, my class, and you guys already were ahead of the game. You knew that tides were affected by the moon or controlled mainly by the moon, and so that's a good start, good foundation. So the moon is a natural satellite. It orbits the Earth because of Earth's gravity, and we talked about this too with moon phases. This happens once a month. It revolves around Earth once a month. That's why we call it a month, one revolution of the moon around the Earth. And then we see different things in our night sky. We see different shapes of the moon. Those are called phases, right? We start at 0, 12 o'clock, and then we grow up to a full moon, which is 100%, and then back down to 0, which is what we are at right now. I don't know if you guys noticed that when you were out making trick or treating last night, but we are at a new moon currently. What's causing these phases? Again, the revolution of the moon around the Earth. We have new moon, waxing. Remember, waxing means to increase, wax on, wane off. Waxing crescent, that's that 25% moon. Then we have first quarter because it's first quarter away around the revolution. Then we have waxing, which is increasing, gibbous, which is a 75% moon, up to that 100% moon, which is a full moon. And then we begin to wane. We wane off. So we're coming back down from 100%. So waning gibbous from 100 to 75%. Then we have our last quarter because it's the last quarter of the way around the revolution. And then we have our little sliver, our waning crescent, like a crescent roll that you get on Thanksgiving. So skimming through this first part here, obviously, because we've already done this if you watch the lectures, this is a really great opportunity for you to practice those moon phases. Please do this in your self-paced Nearpod, okay? Now to what we're really talking about today, which is tides. In most places around Earth, most places around the oceans, let me say that, have two high tides a day and two low tides a day. Okay, so high tide, that's when the water comes in, water comes up. You may have experienced this at the beach where you're sitting there, you may take a little nappy nap with your feet in the water and wake up and you are fully sitting in the water, and that's because tides are coming in, right? And then we also experience low tides, okay? And this is all because of a tidal bulge. I'm not going to play the videos in lecture, okay? Let's see here. I'm going to move over here to some pictures and kind of explain this a little bit better. So the tidal bulge follows the moon. Okay, so as the moon orbits around the Earth, the bulge itself follows the moon. Now, Earth is also spinning. You can see that in this picture right here. Earth is also spinning. That's why if the moon, let's say the moon is at 12 o'clock, that tidal bulge is going to be at 12 o'clock and 6 o'clock. And you're like, wait, why? Why would it be on both sides? Well, without getting too much into physics, it's centrifugal force, right? It's the Earth is spinning so fast that the water is bulging at the pull of the moon's gravitational pull there. So it's bulging on each side, okay? Because again, the Earth is moving at such a great speed. So that bulge is happening, high tide is happening at the moon and directly opposite the moon. So in a straight line, you have your high tides. And I bet you could tell me what moon phases that would be right there, or what moon phase or phase is actually. So the bulge happens where the moon is, and it's always going to move with the moon. I like this one over here too. This is a great picture here. All right. So we have high tide at the moon and high tide opposite of the moon. And we don't get more water or lose water. Therefore, if we have high tide in two places, then it makes sense that we also have low tide adjacent to those. So you see at this 90-degree angle here, so we got the moon in a straight line at the adjacent angle there, we have low tides. Okay, so as the Earth spins, and you can see if you were here, if you were this little person standing here at the high tide, and you spun all the way around and came back, you would experience high tide, low tide in a 24-hour period. Now, there are some extreme tides. Okay, so there are some extreme tides, and kids typically get the idea of the spring tide. Let's look at that spring. Easy. Okay, so a spring tide happens, and a lot of people say the sun doesn't affect tides. Yes, it actually does. When we are at a new moon phase, or when we are at, let's pull up this picture here, when we're at new moon and we're at full moon. So two extreme moons here. Think about that. Use that word, extreme moons. We have the sun, the moon, and the earth, and it's just like tug of war, right? You have two people on one side, you have one on the other, right? And those two people are working together. They're working together to pull on those tides. That's what's happening here. So the sun and the moon are working together. So the sun has very little control of the tides, but it still has gravitational pull. And so when the moon and the sun line up at that new moon phase and that full moon phase, we have these extreme highs, right? Extreme high. So we have extreme high, but on I just told you just a few minutes ago, we don't gain water, we don't lose water. So the thing that typically is hard for kids here is that when we have an extreme high tide in one place, we also have extreme low tide in the other. Okay, so just like that picture we looked at just a minute ago, let's see if this is a little bit better. Just like so here on the sides, you can see up here. So we got new moon, full moon. These are the two phases where you have these extreme tides. Okay, so twice a month we have an extreme high, and that one typically everybody gets. But don't forget that on the opposite side of that, or adjacent to that, we also have an extreme low. Again, we don't get more water. So it has to come from somewhere. So if it's extreme high in one place, it has to be extreme low in another. Now, the second type here is called a neap tide. And a neap tide, kind of like, like spring sounds very active, right? Well, neap kind of sounds like neap, right? It's very calm. And the neap tides happen at two moon phases as well. So when the moon, which is in greatest control, is actually working against the sun, which has just a little bit of control. You've got the moon pulling with all that force, but you got the sun pulling back just a little bit at that 90-degree angle there. And what we get is kind of this moderate or even tide all the way around. Okay, so moderate, neap, spring, extreme. Just don't forget extreme high and extreme low. So we got spring tides, extreme high, this is alignment, and then neap tides. This is moderate. It's where the moon and the sun are at 90 degrees. So again, still working off the concept of Earth, Sun, Moon alignment here. Okay, and that is all your self-paced stuff there. And that's practice on the moon phases. And I think we're about to switch gears here. We are. We're going to move on over to eclipses. I told you that would be fast. So now we're going to talk about eclipses. Again, still looking at predicting motion of orbiting objects in the universe due to gravity. Okay, so again, Earth, Moon, Sun alignment. What does that look like for phenomenon? Okay, when do and why do eclipses occur? I know that we have all experienced eclipses here. I think last year we experienced a partial, right? My kids got to go out in the yard and look at that partial eclipse. That's pretty cool. A couple of years ago, maybe more than a couple, 4 years ago, 5 years ago, we had a full or a total solar eclipse. That was super cool because I was teaching face to face. and our kids got to go out on the football field, and we had these special glasses, and it was so cool because as soon as it reached totality, the crickets started coming out, the birds went quiet, and everything in nature just paused, and it was quiet. And it was so eerie. So then the sun comes back out and things go, or doesn't come back out. The moon moves and the everything goes back to normal. But it was a cool experience. I hope you guys got to experience that. So we have experienced a couple of different lunar eclipses as well, mostly partial here recently. But eclipse means to cover up. Okay, eclipse means to cover up. I don't know if you guys have ever read or watched Twilight, but one of the movies is called Eclipse in that movie because everything is being covered up in that movie. That's one of the worst ones in my opinion. But anyway, eclipse means to cover up. And if you think about it like this, there's two eclipses, solar and lunar. You know, El Sol means sun, right? Lunar means moon. And so if you just think about it like this, to cover up, solar eclipse means to cover up the sun. Lunar eclipse means to cover up the moon. Okay, so that'll help you out. A little bit of vocabulary there. Here's a picture of a lunar eclipse, or sorry, solar eclipse in Chile. And you can see that this is total solar eclipse here. And look how eerie that is. Look how eerie that is. Okay. Moving forward, take some time to look at that when you are going through the. Sorry, guys, I had to pause it right there. I had somebody knock at the door. So, solar eclipse when the sun is being covered up, lunar eclipse when the moon is being covered up. Okay. Take some time to look at that picture in your self-paced Nearpod. We do have some vocabulary here. Total, of course, means the entire thing is covered up. Partial, part, and then penumbral, lunar eclipse. Those words, penumbral, umbral, those you don't have to know for our standards. But if you wanna get a little extra, get a little ahead, Google those and see umbral and penumbral what those mean. It's within the cones. Okay. I'm gonna move through that and that. Total is the same thing. We have annular, total, partial, hybrid. Again, umbral and penumbral, you'll see those words too when it comes to eclipses. Let's go back here. I want to go back, sorry, and look. The door kind of threw me off.
A lunar eclipse happens when the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only takes place during a full moon, which happens once every 29 and a half days, or the length of one full orbit of the moon around the Earth.
All right, so let's flip over here and look at our little, let's do our Google image over here. Lunar eclipse, because this is it makes sense, and it's all really tied together with our moon phases. Okay, this is a great picture. I'm going to share this with you. All right, so take a look at this. Lunar eclipse occurs when the Earth's shadow, the moon, just directly comes into Earth's shadow. What's causing that shadow? Well, the sun. The sun's the light, right? The source of light. So the Earth's shadow there, you can see now. Some people think that the moon is like this two-dimensional thing, like it just moves in the same little route on the same scale, and everything is easily aligned straight across, right? Straight across on a horizon or a line. That's not the case. Okay, the moon actually its orbit is kind of tilted around the Earth, and so this doesn't happen every full moon, because I know that's the next question out of your mouth, right? Well, why doesn't it happen every full moon? Well, the answer is because it is tilted in its orbit, so it doesn't do that every single time. Okay, and you also have to be in the right spot around the Earth in order to see this, especially a total. There's those words, umbra and penumbra. Then we have our lunar, let's see, our solar. Go down to video mode here. All right. This is the one that you
solar
cannot
eclipse
look
happens
directly
when
at,
a
right?
new
You have to have
moon
those
moves
special
between the
glasses.
Earth and the sun, blocking some or all of the
And I know one of the questions that's coming up in your mind is, well, if 100 million Earths can fit inside the sun, how in the world could our little bitty moon cover up the vast photosphere of the sun? The answer to that is distance, right? The sun is 93 million miles from Earth, and our moon is only 283,000 miles from Earth. And so, like, the distance matters, right? So they're about the same size distance when we're looking at it from a distance here on Earth. And so this occurs again. This is going to occur. Let's flip over here so I can give you a good visual. Solar eclipse. Okay. And this occurs at the new moon phase. All right. This only can occur at the new moon, where lunar can only occur at a full moon phase. And again, you can see that there is alignment here between the sun and the earth and the moon. I also want to point out one more time that the reason this doesn't happen every new moon is because the moon's orbit is not exactly on the same plane as the earth. It's not on that same line. Let me see if I can find a picture of that. Ah, there we go. Great picture right there. Okay. And so this is what we got right here. This is, I mean, so you can see this. So it's not on the same, they're not all just level, right? So the moon's orbit is tilted at about 5 degrees and as it moves around the earth. And so that's why we don't see a solar eclipse every new moon or a lunar eclipse every full moon. Okay, so again, that orbit is tilted, just like the Earth's axis is tilted. That's where we're going next into seasons this week, right? And I think that's all we got. I just told you why it's rare, so that's answered that question. And it looks like that's the end of this. Make sure that you do a really good job of answering these draws, and the quizzes in the self-paced Nearpod. That's really going to let us know, be able to formatively assess whether or not you got this information. Again, all of this is so intricately tied, right, to the phases of the moon. The phases of the moon, eclipses, tides, all of those things are because of Earth, Moon, Sun alignment or disalignment. Okay. All right, guys. Hope you enjoyed that, and I'll see you next week.